So in geometry, a point is a location in space, but it doesn't actually have any size. It's kind of a weird idea. So it's kind of like a point of dust that's like floating, not moving. But it actually doesn't have any size. So if you want to name a point, well, what do you say? Just say point A or whatever. Or if the book says what point is on the line, you could just say A. All right. So point A or A or whatever. So that's points. So what's something in real life that's like a point?
Like the tip of your pencil.
Tip of your pencil. Yeah. Okay. Now the next thing is what? The line. Okay, why did I draw arrows on the line now?
Because they keep going.
Huh?
Oh, really?
It goes forever, yeah. In geometry, lines are supposed to go forever. Now, for us, when we work with lines, they don't go forever. But you can kind of think of, if it's part of a line, it's on the line, so you can kind of still think of it as a line. What in this room, what in this room, or yeah, just in this room, what's like a line?
My pencil.
Pencil?
Not right now.
Okay, the edge of the board. Okay, yeah, anything like, a lot of edge, all these edges in here. Like
The arm of the clock. Hand.
Okay, the hand on the clock. Okay, those are all like lines. So, but in geometry, lines go forever. We can't draw them forever though, so we just put these arrows. To name a line, sometimes they'll put a little letter in the corner. So you can say it's line N. Okay, sometimes they do that. But more often than not, like as we go through this year, they will have points that are on the line. And you could call this line like AC. Okay, so you write the two letters and the line symbol on top. All right. How many lines go through any 2 points?
One.
There's only one, right? So that's why you need two letters. Is there another line that's going to go through these 2 points? No, that's not a line. So only any 2 points describe one line. So if I call it line AC, there's only one line I could be talking about. So do not call it line ABC. That's a no-no. Also, if they put a little N over here, like don't say it's line N with that symbol. That's not right either. Just say line N. Okay. So is line AC, is that the same thing as line AB?
Yeah.
Why is that the same?
Because it's going in the same direction.
Okay. Yeah, line AC, am I just talking about from here to here on line AC? No, I'm talking about the whole thing. Is line AB just talking about from here to here?
No.
No, I'm talking about the whole thing. So these are the same. Is AC the same thing as CA?
Yes.
Yes.
I meant to say yes.
There's no order. We're just talking about this line. There's not like a left, right, right, left. Okay, lines, they don't have any, kind of like points. They don't have any thickness to them, so they're like impossibly thin. And then, okay, after lines, what do you think this thing is? Okay, it is a shape, but it's not a shape today.
A plane. A plane.
This is a plane.
Yes.
Okay, it's also a parallelogram or a quadrilateral, but we're not really talking about that stuff today. It's a plane. So planes are flat surfaces that go forever, kind of like lines. But we can't draw something that goes forever, so we just draw like a parallelogram. But anyway, it just looks kind of like this. So to name a plane, They might put a little letter in the corner. So you could say this is plane M. Or, and sometime, let's just do this. Sometimes these points, forgot the Z. Sometimes these points might be like on the corner over here, corner of the plane, but another way to name a plane is use 3 non-collinear points, like plane X, Y, Z. Well, I haven't defined collinear yet, so I need to stop and do that. Maybe you guys can guess. What do you guys think collinear means? What's co mean?
Like 2.
Together or with? And what word do you see in there?
Line.
So if I said collinear points, what do you think that means?
2 lines or more than 1 line.
Or points that line on the same line.
There you go, Whitley got it.
Not really in the book.
That's
Yeah.
what it's there for.
So when it comes to 2 points, we kind of already talked about this. Any 2 points are going to be on one line. But if you have a third point, that could possibly not be on the same line, right? So these would be collinear points, and these would be
Non-collinear.
non-collinear points. So non just means not, right? Yeah, so collinear points. So in a plane, to name a plane, you could use 3 non-collinear points. Why is that? It's because, actually you could use more than 3, but you need 3. If let's see, I need to, let's say this little marker is my line here. If I had 3 points on this line, is it only going to be covered by one plane? Well, we could have a plane going like this. Imagine it's like a sheet of paper. That would touch all 3 points. Or it could be going like this. That would touch all 3 points. Or it could be going like this. That would touch. So if you have collinear points, there's actually a lot of infinite planes that could touch it. Does that make sense? But if you have non-collinear points, 3 non-collinear points, there's only one surface, one plane that would touch all 3 points. So if I picked this point up and moved it out like this, it would be covered by this point, for example. So anyway, so what do you guys think coplanar points are? Okay, coplanar points are points in the same plane, like this. X, Y, and Z are in plane M. Or you could say they're on plane M. Or you could say they're contained by the plane. Plane M contains X, Y, Z. Is it possible for 3 points to be non-coplanar? What do you guys think of that? You think it's possible?
No.
Okay, so let's say here's a couple points and my fingertip is another point. Would that be covered by one plane?
Yes.
Yeah. Could I move it in any way where it wouldn't be covered by one plane? Move stuff around? No, it's kind of hard to think about, but, or draw a visual, but any way that you move 3 points, it will be covered by one plane. How about 4 points? Is it possible?
Yes.
Well, they could be coplanar. Is it possible for them to be non-coplanar? Okay, here's 3 points. They're coplanar, right? My smart board's a plane. Okay, if I have a 4th point, now are these 4 points coplanar?
No.
No. Is there anything if I try to pick this up to cover this, it's not going to be touching that, right? So it is possible for 4 points to be non-coplanar. Okay. Another word, this one's totally new. Actually, let me start with, how many times can two lines intersect? At most once, right? It's not really possible, like this picture, those are not lines. Okay, so when two lines intersect, the book calls them, I don't really like this word, but I would just say intersecting lines, but the book calls them concurrent lines. So concurrent lines intersect at one point. Do two lines always intersect? What else could happen?
Excuse me, parallel.
Parallel. Okay, so they could be like running right next to each other, going the same direction, never touching. Is that the only two options? Two lines either touch at one point or they're parallel. Is that the only two options?
Yes.
Willie's saying no.
Yes. Sure.
Willie, we're changing your answer there.
No, please. I didn't deserve this. You spelled my name wrong. That's not me.
Now, right?
That's the Whitley that was under your desk. W-H-I. Why am I telling you? T-L-I-E.
Yeah, okay.
Ooh.
I was answering the question. You're breaking my heart, Mr. Jordan. You just ripped it in shreds, actually.
Okay, so here's my arms are lines, so this is intersecting concurrent. This is parallel, they're not gonna touch. What about if they go like this?
No.
Is that intersecting?
No.
Is it parallel?
No.
No. So what is it? Well, it's kind of hard to draw this,
Non-concurrent.
by the way, because you're supposed to somehow represent that they're never gonna touch. So when you see dotted lines, that means it's like in the background. That's about the best I can do. So if they are never touching, but they're not flat like parallel, it's called skew. So what makes parallel, you guys probably never thought about this, is they have to be on the same plane. They have to be flat together. That's what makes them parallel. Not only do they not touch, they're also on the same plane.
Wait,
So skew lines are not,
parallel, not parallel?
yeah. Skew lines are not on the same plane. They're just going all kinds of different directions. And they never touch.
So what is this called?
Skew. Anytime they're, yeah, on the same plane. Let's see. All right. What definitions did I skip? Check. Can planes be parallel? Think about it. Can planes be parallel? Think of like a sandwich. Pieces of bread. Can planes be parallel? Yes, they can. Can a plane and a line be parallel?
Yes. Yes. Yeah.
Kind of like what?
Okay. Can a plane and a line be parallel? Yeah. Yes, they can. Basically, if a line's on a parallel plane, it's going to be parallel to the other plane. All right. So if I draw a line like that, that means the line is in the plane or on the plane, or you could say it's contained by the plane. But what if I want to show the line going through the plane? How would I draw that? Let's just get that guy out of there.
Oh.
Okay, you go kind of like that, and then it's like, that's where it hits intersects the plane. And it's dotted. Why is it dotted? Because the dotted part is on the back side of the plane. Like you're,
Kind of like when you draw a box.
okay, the picture wouldn't make sense. So this is like the part that we should be able to see right here, and this is the part we wouldn't be able to see. Does that make sense? Yeah, like the box, when we draw a prism like this dotted part is on the back side. Right? Alright, so the same thing with the planes. That means it's going through the plane. So I could say line N intersects plane P at point T. Alright? Clear as mud? All right, page 8, you guys there?
Sure.
Yeah. Gave me a nasty look.
I can't even focus now.
You're gonna start crying. Okay.
I think you were my favorite teacher. Here we are.
Clearly the feeling is not mutual.
Yeah, thanks, Mr. Jordan. I appreciate it.
Okay, point K. So it says we're supposed to draw a picture illustrating. So how would I draw point K, do you think?
A dot and
A dot and a K. You guys are geniuses.
Oh, that's so crazy.
Okay, number 3, line L. Okay, so they use an italicized L so it doesn't look like a 1. I use a cursive L.
I use a capital L.
Yeah.
Yeah.
Let's do the capital L.
When they name planes and lines, they usually use lowercase letters so they don't look like they're points, which they use uppercase letters for points.
Well,
Okay, anyways,
you want me wrong?
not a big deal, no. Number 5, write a description of the illustration. So what's going on in number 5? Point F, what? Is in plane in, or you could say it's on plane in, or whatever. Point F is on plane, what was it, in? Or you could say plane in contains point F. All right, what's going on in number 7?
Line in intercepts plane F.
No, number 7.
That's my fault.
Number 7.
And it would be intersect, not intercept. Although that's pretty close. So what can we say about point Q on number 7?
It's there.
Point Q, what do we know about it?
Starts with a C.
Point Q is,
Did you say parallel?
no, points can't be parallel.
That's weird.
It's just like points, huh?
Starts, I don't know.
Point Q is it on the line?
No.
No, it's not on the line.
Is away.
Is not on line L. Okay. Narrow line. KL. Now everybody's gonna come in and say, why is Whitley's name on the board?
Yeah, with an extra mark.
And they'll say, she got in trouble.
You know that day my brother was like, you got your name on the board? And his board was on the name, his name was on the board every other day. He had no right calling me out.
Kind of challenging to get the middle schoolers to shut their mouths. All right. Name the line that contains point K, or lines, plural, that contain point K. So what lines contain point K in the picture?
KM.
K. So why can't I just say line M?
Because N is going towards N too.
Okay, M is not a line, it's a point right there. So when they put a letter next to the intersection, they're talking about the point of intersection. M is a point, so that we don't know if you mean this line or this line. So you have to use 2 letters, just like Willie said. So it's line KM. What other line contains point K?
KL.
KL. Now, even though they didn't draw it, KN But since they didn't draw it, you don't have to write it. KN would be another answer. But usually if they don't draw the line, you don't have to write it down. That's the general rule. Number 11. Oh, by the way, does the order of these letters matter?
No.
No. So when we grade it tomorrow, are you guys going to be confused?
No.
We'll see about that. Number 11. Which pair of lines appear to be parallel? We don't know for sure, but it looks like which lines are parallel.
KO.
KL.
MN.
So we're going to put line KL. You do need to put the line symbol and all that. You guys remember the parallel symbol maybe? I might have mentioned it last year. That's it. It's just like a really thin 11. Line KL is parallel to MN. And what? What else?
And KM is parallel to LN.
KM is parallel to LN. Okay, 13. So some people have trouble with these three-dimensional pictures that are like just a bunch of lines drawn together. Hopefully when you look at number 13, you guys see a box like in the corner of the room. That's what you should see. If you turn it upside down or look at it sideways, it gets more confusing. But
Whoa.
you might not want to do that. Just keep it right side up. It'll screw up your vision.
Yep.
Crap, now I can't.
Those, I'm not sure if we even need them, but those, do you guys see the dotted lines? Those are like diagonal lines from F to C and B to E. I don't remember them asking about those though, so I don't know if we need them, but anyway, that's what's going on there. So 13 says, name the planes whose intersection is AB. So do you guys see line AB in the picture? Okay, what two planes? So AB is like the corner of the room in that picture, right? So notice on this corner of the room, like the bottom corner, that's a line, right? That's where the wall and the floor meet, is all along this line. So in that picture, what two planes are meeting on that line AB? Planes M and N. See, notice how they named the floor M and the left wall N in the picture. So I'm just going to put planes M and N. So we could call the floor in that picture like plane ABCH or just plane ABC. But since they put a letter down there for us, we can just call it plane M. It's easier. And the back wall is like plane P in that picture. Okay, anyways, number 15. Name three concurrent lines. So what did concurrent mean? What are concurrent lines? Lines that intersect at a point. So intersecting lines. So 15, what are three lines that intersect at point H? That they drew.
AHC.
That's not a line.
A.
AH, line AH, that's one of them.
EH.
And EH. Line EH.
CH and EH. Yeah. Okay, 17. What relationship is demonstrated by lines GD and EH? You guys see GD and EH? So, what kind of lines are they? The options are like, are they concurrent, are they parallel, or are they skew? Skew, yeah, they are. They are not on the same plane, they're definitely not touching. Not gonna touch. So, those lines in the picture are not infinite, you just gotta imagine them being infinite, I guess. Something that confused the other class a little bit. You guys see in that picture line, let's say AF. You guys see AF in the picture? Line AF. How many lines in that picture are parallel to AF?
3.
There are 3.
3.
Yes, he's right. Okay, basically, any line that's going straight up and down is going to be parallel. Now, they didn't draw every plane possible. Like, they didn't draw a plane AFDC. But that is a plane in there, even though they didn't draw it. So, any line going straight up and down is going to be parallel to AF. Okay? So, there's 3 answers on those kinds of questions. Anyway. All right, jumping down to 30. You guys see we're jumping here. 30, always, sometimes, or never. It's not quite true, false, but concurrent lines intersect. It's number 30. Does that always, sometimes, or never happen? Always, because that is the definition of concurrent. They intersect.
Is it always?
31, skew lines intersect. Never. Never gonna touch. (32) Parallel lines are skew lines. Never. Parallel has to be on the same plane. Skew line has to be on different, not the same plane. 33. 2 points are non-collinear. Is it possible for any 2 points not to be on the same line? Okay, they might not draw it, but any 2 points will be covered by one line. So is it possible for 2 points to be non-collinear? No. Never. Okay, 34. 2 lines are coplanar. Is that possible? Always, sometimes, or never? Sometimes. Skew lines would be not. (35) 3 points are coplanar.
Always.
Is it possible for them not to be? We kind of already talked about this, didn't we? Yeah, we talked about it, but yeah, any 3 points will be covered by one plane. So you guys were right, always. Uh, 36, right? 4 points are coplanar.
Never.
Always.
Sometimes. And 2 intersecting lines are, this might be tricky. I might have to think about this one. 2 intersecting lines are coplanar.
Always.
Okay, is this covered by a plane?
Yeah.
This, this, yeah, always. That's actually something we're gonna learn like on Friday or something. I don't know why they threw it in there, but